The section's on 5.2 exponential functions and graphs. So what we're going to be given is something like similar to this, where you have f of x is equal to, and then normally this is either a fraction or a whole number, and that's called a base, and then you're going to have an exponent up here. So the exponent you'll definitely have is an x. Sometimes you'll have a negative x, sometimes you have an x plus something, or a negative x plus or minus something, and then you'll also have is this part down here, which comes down from the exponent, and it's pretty much the same size as the base right there. So this is what we're going to be given, and then we're going to be asked to graph this out. Okay, so I kind of made it as a general statement right here, so that way you can kind of see. Also, this is a negative, not a little line underneath it. So you can see the different ways of this being presented, and it's the exponential function. So when we look at the base, which is this part right here, if the base number, a, is what I call this, just to give it a general name, if it is greater than 1, then your graph is going to increase. So, for example, if you have as 2, a big 2, and then to the x power, it's going to increase. So increasing means the graph is going to go like upwards, right, for increasing part of it. And then when the number is less than 1 and between 1, so normally that's going to be your fraction. Sometimes they actually put in decimal as well. So if it's either in fraction or decimal, and it has to be in between 0 and 1. So if it's 1.2, then it's actually greater than 1. So that's the tricky part. So you're going to have is increase. Okay? So if it's between 1 and 0, then it's going to decrease. So the picture is going to come downwards instead. Okay? Then we have a negative in front of the a, so that's when this comes in play. So you won't always have a negative in front, but if you do, then the picture will reflect over the x-axis. So it's going to flop down from the x-axis. Okay? Now, let's talk about exponents. So now exponents is going back to up here, so anything that's up in the top part of it, the exponents. So if the exponent is greater than 0, it's going to shift to the left. So if I have something like this where the exponent is either x plus 3 or x plus 5 or something, some number greater than 0, so it's a positive number, then your graph is going to totally shift to the left part of it. Now, the way I remember this is if I set the parentheses equal to 0, right, you're going to have as x equals negative 3. And if you have negative 3, you have to go to the left because negative is to the left. So that's how I kind of remember this part right there. Okay? Now, if b is less than 0, then this graph is going to shift to the right, so which goes the opposite direction on that one. And if you have a negative on b, so it's going to look something like this. If you have a negative in front of that x right there, so if you have a negative in front of it, it's going to reflect over the y-axis. Okay, so those are some rules. If you know those rules, it makes it easier to do the graphing. Now, if you don't know the rules, that's okay. Then you're going to probably have to create some tables and then go ahead and graph it out. Okay, let's also talk about C. So C is this last part right here. So if C is greater than 1, the whole graph is going to shift up. And if C is less than 1, then the whole graph is going to shift down. So it means that if this is a plus something, then it's going to be obviously greater than 1. So the whole graph is going to shift up. If it's minus something, since it's negative, it's going to shift down instead. Okay? So this is up and down. This is right and left right there. And then the reflections over the y-axis and reflection over the x-axis. Those are your reflections right there. Okay? So let's do something like this, an example. So what I did was I took, this is what it looks like. Something similar to this. Now again, if it is greater than 1 or less than 1, that's going to affect the picture right there. So in this case, I took this pretty much the same equation, and I just added little details of numbers and negative and things like that so you can see what the original graph is. So this is the original graph. And this is sometimes called as the parent graph, as you may hear it sometimes, okay? So this being the original graph, we're going to graph this out. Now, if you don't know what that graph looks like, then you're going to go ahead and create X and Y tables. So we should be now comfortable with X and Y tables because we've done plenty of X and Y tables on rational equations and things like that. So you have X's and Y's. So if I substitute in, like, for example, X of 0, Then you're going to go 2 to the 0 power. Anything to the 0 power is equal to 1, right? Then we have is 1. 2 to the 1 power is equal to 2. And then 2 to the second power is equal to 4, right? Because that's 2 times 2 is what they have right there. So then when you graph this out, you're going to graph it out at 0, 1. So 0, 1, you're going to have as a dot right there. At 1, 2, so at 1, 2, so you're going to have a dot right there. And then 2, 4, so 2, 4, so something like this right there. Okay? Now the graph of this exponential is going to go something similar to this, where it's going to come really, really close to, now it's going to use the y or the x-axis as an asymptote, so it may come really close to that, but never touching or crossing over it. And it's going to come over here, and it's going to come up, and it's going to gradually go up this way and then shoot up to infinity right there. Okay? So this is what 2 to the x power looks like. Now, negative 2 to the x. So that now goes back to our base rule that we set up here. So if I have right here a base of a negative, which is this part right here, it reflects over the x-axis. What does that mean? So if I know what the original graph is, which is this part right here, it's going to reflect over the x-axis. So the x-axis is similar to when we did the inverse graph, right? On this last section, you had to have y equals x to do kind of like that folding line. Well, the same idea as this part right here. This is the folding line. So if I folded the line, this graph is going to reflect, and it's going to go over on the other side. So when it goes over to the other side, it's going to look something like this. It's going to come close to that negative 1 this time, and then it's going to shoot downwards instead, because that's the reflection of the previous graph right there. Okay, so that's what it looks like for negative 2 to the x. Now 2 to the negative x, what does that look like? So going back to that now is the exponent. If I have a negative on the exponent, which is this part right here, then it's a reflection over the y-axis. So when I take this graph right here, which is the original, is this part right here, we're going to flip it over on the y-axis right there. So the y-axis flip is going to be, now this direction is going to be the tail for that part right here, right? So that's the tail right there. And then this is going to shoot up, so I have to shoot up going this direction right here. So that's going to be like the mirror line. So the y-axis now becomes a folding line. So you'll see exactly is what it looks like on the right-hand side of each part of the graph right there. Okay? The next one we have is 2 to the x plus 3. So 2 to the x plus 3, we said that if it's a plus 3 right here, we set that equal to 0. So that's kind of like 2 to the x. And then we have is equals negative 3, right? So negative 3 means we're shifting this whole graph, which is originally this graph right here, right? Because this is the graph right here. So we're going to take this and we're going to shift it 3 spaces to the left. So I usually just go like this as being the key point right there. I would just move from here to 1, 2, 3. So that's going to be the belly of that graph right there. So I call this the belly right there because that's the point that's going to move. So which is this part right here. So now here we're going to do exactly the same thing. We're going to graph this out right here. The only difference is that we have is a shift. So when you shift it, everything's going to be the same. But when you get to here, it's going to start to curve and then take off right here. Because the curve part of it right here, that's this part right here, the curve part of it right there. Okay? And then we have is 2 to the x power minus 4. So again, this is the original graph right here. If it's minus 4 is the C part right there. So if it's less than 1, it shifts down. So it moves down 4 spaces. So from that 1 right here, we go 1, 2, 3, 4 right there. So we're going to go ahead and shift this whole equation, but down 4 spaces. So it's going to go something like this. And it's going to go here, and then it's going to take off from here and go upwards, something like that. Okay? So that's the exponential part for this graphing portion of it. So again, if you don't know or if you're in doubt, I would always just go by the table right here. Just substitute it into the original equation, which is usually this right here that's given. Just go ahead and substitute that in and then figure out what the y value is, and then just do little dots and then connect the dots from there. But if you know each of the rules, it just makes it easier when you graph them out. Okay? So one more example that we have. Now this right here is usually in a word problem and usually is dealing with interest, compounded, money, things like that. That's when you're going to see this. So on this example, it says compounded interest formula. And this formula is given. It says A is equal to P, parentheses, 1 plus R divided by N, close parentheses, and then N times T. So now, from here, what does the P represent? P represents the principal dollar amount. So let's say you go to the bank, you have $100, you put $100 down in the bank, and they said that it'll grow after so many years, and you want to know is how much will it grow or something like that. That's when you're going to put in this money right there. Okay? So then the rate, they're going to give us some kind of percentage. They'll say maybe the bank, if you put the money in, it's going to grow 3%. Well, if you have 3%, that percentage needs to be changed to a decimal instead. So when you give an answer, make sure it's in decimal. If it's not in decimal, it is wrong. Okay? So 3%, does everyone know how to do that shifting part of it too? So the way I usually remember it is, this is D for decimal, P for percentage. So when you go like to the decimal, you have to move it to the left 2 spaces. If you have to go to percent, you have to move it right 2 spaces. So for example, let's say 2% is what we're given. So percentage is here, and we need to get to D. So that means from the back part right here, technically it's 2.0, right? So from the back, we're going to move 2 spaces to the left. So that's 1, 2 right there. So it becomes 0.02. So that's going to be the number that you'll use when you put it into the calculation, not the percentage part of it, just the decimal part of it. Okay? Now let's say you go the other direction, but you won't actually in this kind of problem. But let's say you do, are given in decimal and they want you to find the percentage of something, then you do the opposite. So similar to the same idea right here, you would move your decimal place 2 spaces to the right instead and find the percentage. Okay? The next one we have is time. So time is going to give us, normally in years, that's your time right there. So time is going to be given to us right there. Compounded, so that just depends on what the N right there says. So if it's compounded, and then we want to do some charts to this. So normally it'll say annually, then it's going to be a 1 is the number we want. If it is compounded semi-annually, that means 2, because there's a semi-annual sale, means that it happens usually twice in a year. Quarterly is 4. Daily is 365, and then monthly is 12. So those are the numbers that you would normally use for your T part of it right there, okay? Once you have all of this information, then that's the easy part, and just making sure everything gets put in the calculator correctly. So when you put it in the calculator, if you have a scientific calculator that allows you to do parentheses, make sure you do your parentheses right there and put it up as an exponent. Everything should be fine the way it is, okay? Now, if you don't know how to use your scientific calculator, or if your scientific calculator does not do parentheses to some kind of exponent, you may have to do little chunks at a time. So for the first chunk you want to do then is the decimal divided by the compounded something, added to 1. You're going to get that number right there. So once you get that number, then you're going to take it to the exponent of the number of years and also the number that the teacher or whoever puts in, actually. For the money part of it. And then this is going to be the final part, which is then the final money that is deposited or started. Okay? So that's the compounded interest formula part of it.